Lesson 1-12, Integral Exponents. In this lesson, we're just going to review how to write repeated multiplication in exponential form and then use some of the laws and rules of exponents. So first off, exponential form is just an expression that contains a base and an exponent. The exponent tells you how many times to use the base as a factor. And then you might hear like the power. Power is just the equivalent standard form of a number in exponential form. So if I said 5 to the third power, that would mean in exponential form with the base of 5, the exponent of 3. And in factor form, that would just be 5 times 5 times 5. So what laws and rules of exponents are we going to be looking at today? We're going to be looking at the product rule of exponents. And the product rule of exponents says when you multiply like bases, you add the exponents. The quotient rule of exponents says when you divide like bases, you're going to subtract the exponents. Then we're also going to look at the zero power rule, which just says any base raised to the power of 0 is equal to 1, except for the base can't be 0. And then negative exponents, you write the reciprocal of the base to make the exponent positive. So let's take a look at some examples. Here we're using the laws of exponents, so we're multiplying. The bases are the same, so I take my exponents of 3 and 2 and add them together, and this is going to give us negative 2 to the 5th power. And if we were to simplify that further, put it in standard form, negative 2 to the 5th power would give us a negative 32. But for right now, we just need to put it in exponential form, which would be negative 2 to the 5th power. With division, the bases are the same, so if I divide the bases, I take the exponents and I subtract the exponents, so 5 minus 2 would give us 6 to the 3rd power. The zero exponent, anything with a base other than 0 raised to the 0 power is just going to be 1. And negative exponents, so if I have 4 to the negative 1/2 power, the reciprocal of 4 is 1 over 4, and then the exponent is now going to be positive, so 1/4 to the 2nd power. And then if 1/4 is the base, the reciprocal of 1/4 is 4, and then I square it with a positive 2. Next, we're just going to simplify these. Here we have like bases, so 2 minus 3. This is going to give us 5 to the negative 1st. 6 to the 5th divided by 6 to the 5th. 5 minus 5 is 0. 6 to the 0 power. And then we have 7 to the 4th divided by 7 to the 2nd, which would be 7 to the 2nd power. So if I simplify that, we end up with 49 on top, because 7 squared is 49. The reciprocal of 5 is 1/5, so that's 5 in the denominator raised to the 5th power is just, or 5th to the 1st power is just 5. 6 to the 0 power is 1, so my answer would be 49/5. Next, a squared times a to the negative 3rd times a to the 6th. When I multiply like bases, I add the exponents. So 2 plus a negative 3 is negative 1. Negative 1 plus 6 is 5, so it would be a to the 5th power. Next, I have just 3/4 on my bases. So in the numerator, I can take my denominator, my exponents, and add them together, and that gives me negative 6. But if I divide the bases, I have to subtract the exponents. So that's going to give us 3/4 raised to the negative 2nd power. Because I have negative exponents, I flip the base, so that'd be 4/3. And then I raise it to the 2nd power. So I should have an answer of 16/9. And this last one over here, I have 4 to the 1st divided by 4 to the 3rd, so I do 1 minus 3. A to the 0 minus a negative 1, so 0 minus a negative 1. So this is going to give us 4 to the negative 2nd, a to the 1st. So my final answer would be A, all over 4 squared, and 4 squared would be 16, so it would be a over 16. And our last samples, here I got 9 squared. This is 81 over 1 times, or not, so here you're going to divide that by the reciprocal. So if I have a fraction, I'm really multiplying by the reciprocal. So let me do that. And if I rewrite 1 over 3 to the negative fourth, that is actually 81 over 1. And 81 divided by 81 is going to give us 1. Next, we have negative 2 as a base. So that means I have negative 2 and 5 minus 0 times 3 squared minus a negative 1. So negative 2 to the 5th power is negative 32 times, this would be 2 plus 1 is 3, so 3 cubed would be 27. So now I have 32 times negative 20 times 27. So let me just grab my calculator here. So we have a negative 32. We're going to multiply that by 27. That's going to give us negative 864. And that is our lesson today on integral exponents.